I'm sharing my screen. Okay, last class we seen the combinational circuits, the test bench for the combinational circuits. In the combinational circuits itself, today we'll see the test bench for 2 cross 1 mux and 4 cross 1 mux. How to write the design code and how to write the test bench for 2 cross 1 mux and 4 cross 1 mux we'll see. Okay, so first we'll see the test bench for 2 cross 1 mux. Okay, one second. Not connected. One second. Yeah. Yeah, we see the test bench for 2 cross 1 marks. Okay, so normally if this is a 2 cross 1 marks, 2 cross 1 marks, and also 4 cross 1 marks we will see. First we'll see the 2 cross 1 marks. First we'll see the design code and how to write the test bench. Okay, suppose here if you see um, so module, and what is my module name? So module, so I told you in the identifiers or module name, so invalid identifiers and valid identifiers. So here this value is number. Okay, so when you are giving 2 cross 1 marks, the compiler will not take. Okay, so how to give means underscore 2 cross 1 marks, underscore 2 cross 1 marks you need to give, and underscore means it will take. Okay, input, so what are the inputs? Input is yes, and input I am giving 1 down to 0. This is a vector. I am giving inp. Okay, inp, this is the input. Okay, and next output, reg, y. So I am using behavioral modeling. Output should be reg. Okay, so next what I need to do? Always at the rate. So what are the inputs in the sensitivity list? I can give the inputs inp s comma inp I can give. Otherwise I can give the star also. Star means what? Implication operator. Okay, that will be applicable for all the inputs. Okay, next begin, if selection line, that is s equal to what? 1. Selection line s equal to 1. So which is connected to the output? So you have 2 cross 1 mux. So 2 cross 1 mux we already seen in the digital. So you have like this is let us take inp0 and inp1, and output is y. Okay, output is y. This is 2 cross 1 mux, and you have how many selection lines? One selection line. Yes, selection line. Okay, so if s equal to 1, so y is equal to what? inp0, y equal to inp0, else y equal to what? inp1, else y equal to inp1, end at end module. Okay, end module. Okay, so that means when you are writing the code, we need to write so like we need to so when you are writing the code, so we can write so which is synthesizable RTL. So we need to write within the assign block, or within the always block. This we already discussed. These are nothing but procedural blocks. Okay, so by using this assign block and always block, we can implement the code into hardware. Okay, we can implement the code, whatever the code you are writing, into hardware. Suppose when you are writing initial block. Okay, one more is there, initial block. So initial block, this is what? This is non-synthesizable. Okay, so this is not non-synthesizable means what? So it cannot non-synthesizable. So non-synthesizable means it is cannot convert into hardware. We cannot convert whatever this one into hardware. Okay, so non-synthesis. So where you are using means this initial block you are using in the test bench. Okay, so this is by using which one? This design for 2 cross 1 mux by using if else statement. Okay, okay, you have procedural
Sir,
statements, no? Any doubt?
sir, if else like a case code on the sir,
Yeah,
case of
yeah, case
respect.
I'm explaining. Yes, case I'm explaining. Next using case only I'm explaining. This if else is okay. Do you understood?
If else I understand, sir.
Okay, understood. Okay, this is 2 cross 1 marks by using if else statement. Okay, 1 second. Yeah, yeah. Next we will go to the case statement. So what is this case statement? So 2 cross 1 marks by using case statement. 2 cross 1 marks using case statement. Case statement. So when you do the 2 cross 1 mark by using case statement, so here first you write with module. What is my module name? Underscore 2 cross 1 mux input yes. Okay, better to input this is input s, better to write in vertical only. Okay, so why? Because in industry they will include this in vertical only. So it is easy to debug. Suppose 100 inputs or 150 inputs are there, so if you are writing vertically it is easy to debug. Okay, input 1 down to 0 inp. Okay, input 1 down to 0 inp, and output reg y, output reg y. Okay, so reg y, so always at the rate star, always at the rate star begin. So you need to begin. Okay, I'm using cases, case yes. Okay, cases, if it is like cases, if it is one tick binary 0. Okay, one tick binary 0, so y equal to what? Inp of 0. Okay, if it is one tick binary 1, one tick binary 1 inp, so y equal to what? Y equal to inp of 1, inp of 1. Okay, here in the case statement there is a default statement. Why this default statement I will tell you. So for every statement there is a default statement. Default, you need to use default. Okay, so y equal to you will get tick binary x, tick binary x, end case, and end begin, you need to end, and end module, end case, begin, and end module. Okay, so did you understood this program? Why this is there means I will tell you when we discuss 4 cross 1 marks. I will tell you how to so why this default statement is there in the case statement. Okay na?
Okay, sir. Okay, sir.
Okay, yeah, coming to the test bench. Okay, how to write the test bench. Okay, so test bench for combination circuit, test bench for the combination circuit. First module underscore 2 cross 1 mux, 2 cross 1 mux underscore tb, and no inputs you are giving. Okay, just a bracket. First step 1, what is step 1? You need to declare the internal variables, declare the internal variables. So what are the internal variables? So you need to declare in the test bench input with
Reg,
x data type and output with y data type.
wire,
Yeah, reg. What is the input? 1 down to 0 np, comma inp. Okay, this is inp. Okay, so 1 down to 0, this is inp. Okay, 1 down to 0 inp, and this is yes, this is yes. Okay, and wire y, output to wire. Okay, so next step 2, you need to instantiate the design, you need to instantiate. Okay, so you need to instantiate the design. How to instantiate the design? That means my design name. What is my design name? Underscore 2 cross 1 mux, 2 cross 1 mux unit under test, this is inp 0 comma inp 1 comma s comma y. So how you declared the inputs and output. The same way you need to declare the this one. Okay, so in the instantiation unit under test, okay, this is instance name. Okay, and here you need to write this is connection by position with order list. Connection by position with order list. Okay, connection by position with order list. Okay, so what is step 2? So step 3 is you need to initialize the reg variables. Initialize. Okay, initialize the reg values, reg variables or reg variables. Okay, so initial begin. Okay, so I am using concatenation operator. So in the concatenation operator, so whatever the reg variables inp of 0 comma inp of 1 comma yes, okay, these I am initialized to 0 and end. Okay, so this is step 3. So whatever the internal variables are there, that you need to initialize. Okay, and next step 4, driving the inputs to the design. Driving the inputs to the design. Okay, driving the input to the design means what? Here initial begin. I am giving, that means s equal to 0, and next inp of 0 equal to 1 I am giving. Okay, and inp 1, that is equal to 0 I am giving. Okay, and after 10 time units you give the delay 10 time units, s equal to what? 1. Okay, s equal to 1, and here I am giving inp 0 equal to 0 and inp 1 that is equal to 1. Okay, end and end mode. Did you understood the test bench how I am writing? Your response?
Sir, that's not.
Okay.
Initially begin తర్వాత ఒకసారి explain చేయండి సార్.
Initial begin here, initial begin. So I am giving s equal to, I am giving the test cases. This is nothing but test inputs. These are nothing but what? Inputs. S equal to 0, inp equal to 1. Only I need to give the inputs in the test bench. Okay, so inp of 0 equal to 1, inp of 1 equal to 0. First I am making s. So from the, so that means this is my design. Okay, this is my 2x1 mux on the top module. So 2x1 mux means you have inputs. So this is inp of 0 and inp of 1 is there. Okay, inp of 0, inp of 1, and this is output y, and this is selection line is there. And over the top module, this is my what? This is top module. Okay, this is my TB, test bench. Okay, so through the test bench I am giving the inputs. Okay, so what are the inputs I am giving? S equal to 0, inp of 0 equal to 1, and inp of 1 equal to 0 I am giving. Okay, so based on these inputs it will execute, means it will design will execute, and it will give the output. So output to what? So here you initialize the input and output, no? So the test bench output will be, let us take y. Okay, same y only. It will give the output to the test bench. So what is the output? So depending on this requirement, I make s equal to 0. S equal to 0 means which is connected? Tell me. INP 0 is connected or INP 1 is connected?
INP 1.
INP 1.
Ah,
INP 0, 1. Here I am given 0, 0, 1. So that means here INP 0 is connected, no? So you are getting y equal to what? INP 0, that is equal to what? You are getting 1. We can see in the simulation. Okay, na? Next case, if you see, next case, so you given, so that means in the 2x1 mux, So here what is this? S equal to 1 you given. So this is 0 and this is 1. INP of 0 equal to what? 0, and INP of 1 equal to 1 you gave. Okay, so 1 you gave, and here this is y. So when selection line equal to 1, which is connected? This is connected. So y equal to what? 1. Did you understood how I am getting? Means you need to give the test cases in the test bench.
Okay, sir.
Okay. Yeah. So will you execute this, or shall I show in the EDA playground? This Vivado. Shall I show this code? Execute and show.
Okay, sir.
Okay. Yeah. So this is 2 cross 1 mux. No. 1 second. I will open this. Yeah. I'll share this PPT. Just you can execute this. 1 second. Yeah. This is 4 cross 1 mux. Okay, 1 second. This one I will open. Yeah. So here I wrote 2 cross 1 mux data flow modeling. 2 cross 1 mux data flow modeling means I told you. So you can write by using ternary operator also, no? Assign y equal to what if select b, otherwise a. With one statement I can write. With one statement I can write. Okay. 2 cross 1 mux by using ternary operator. Okay. And this is 2 cross 1 mux by using which statement? This is by using case statement. Okay. This is by using case statement. And 2 cross 1 mux by using if else statement. 2 cross 1 mux by using if else statement. Okay. So any inputs you can take a, b, selection and y. Okay. Like this also you can take. Okay. INP0 like that also you can take. Okay. So coming to the test bench. Okay. So test bench, this is the case. So here how I wrote this one means test bench. Here inputs I need to include with the reg variable which data type, output with y data type, and here I am instantiating by connection by name. I am instantiating connection by name. Okay, there I said connection by position, any instantiation you can use, and I declared the integer I initial begin. So display selection a, b, and display this one. I am using loop statements. How many inputs are there? 3 inputs are there. Okay, so 3 inputs means 2 cube. 2 cube means how many combinations? 8 combinations are there. Okay, so 8 combinations means I am using for loop also. Like this also I can give the test cases. I equal to 0, I less than 8, I equal to I plus 1, and I am using concatenation operator, select comma a comma I, a comma b equal to I. After 10 minutes I am displaying these values. Okay, dollar finish means you need to finish the finish this one. Okay, So this is using case statement, and for this same only the data, the test bench will be same for all the cases. Okay, test bench will be same for if else case and data flow modeling. Test bench will be same only. Okay, so like this I wrote. So whatever you want to execute, that you need to make a stop module. Okay, suppose this test bench by using state case statement I am doing. So here just you can elaborate the design also. Okay, so 2 cross 1 mux is there, no? So 2 cross 1 mux using case statement, set as stop, and it's closed. 1 second. Yeah, case statement, just elaborate the design. How you are getting the circuit, you need to elaborate the design. Yeah, you got the elaborate design, no? S, A, B and Y. This is the elaborated design. And go to simulation and run the simulation. Go to simulation and run the simulation. So three inputs are there, means 8 cases, like 8 cases you need to check. So in the TCL console also you will get the output. See here, select A, B. Okay, this is the TCL console output. So select equal to 0. So A, B. So you what you will get, A is connected to the output, 0 0 you are getting. Okay, select equal to 0. So that means A it is connected to the output, 1 1 you are getting. Select equal to 1 1. Select equal to 1 means what? B is connected to the output. So whatever the B value is there, you are getting the output. Okay, and select equal to 1. So you are getting what? So B is connected, that is 0 1 you are getting. So 3 inputs are there. How many possible combinations? 8 possible combinations you need to check. Okay, all cases you need to check, and based on the selection line only, and first four cases A will be selected to the output. Next 4 cases selection equal to 1, B is connected to the output. Okay, you can see in the waveform also. See here in the waveform also. So here you will get fit to page. Yeah, see here. So this one, when selection equal to 0, A equal to 0, B equal to 0, Y equal to 0. Selection equal to 0, A equal to 0, B equal to 0, Y is also 0. Selection equal to 0, A equal to 1, B equal to 1. You are getting A. Okay, and selection equal to 0, A equal to 1, B equal to 1. You are getting 1. Okay, A equal to 1. Whatever the A value is there, you are getting. Till here you will get A only. Okay, A value, and from here it will be Y is connected to B. Whatever the B value is there, you are getting. Okay, so here that means Y equal to 0, and similarly Y equal to 1, and again selection 1 0 means selection 1, and 1 0 means Y equal to 0, and next Y equal to 1. Like this you can see the simulation. Did you understood how I am writing the code and how I am getting the test bench? Did you understood? Give response, any doubts or queries?
Yes, sir.
Okay. Coming to the 4 cross 1 mux. Okay, so for the 4 cross 1 mux, so same thing like when you are using, so you can write by using if else statement and case statement. Okay, so for 4 cross 1 mux, if you see the 4 cross 1 mux, 4 cross 1 mux. You can write with if else statement, or you can write with case statement. If else statement or case statement. Okay, suppose if else statement is there. If else statement, how to write? Just I will give the idea. Like so, same thing. You need to initialize. So module. So you need to initialize the module. So 4 cross 1 mux. Suppose 4 cross 1 mux using if else statement. Okay, 4 cross 1 mux using if else statement. Okay, if so that means if selection equal to 2 tick binary 0 0, okay, which is connected y equal to what? inp of 0. Okay, inp of 0. Else if selection equal to 2 tick binary 1 0 0 1, 0 1, which is connected y equal to inp of 1. Okay, similarly if else if selection equal to 2 tick binary 1 0, which is connected y equal to inp of 2. Okay, inp of 2. Okay, else if selection equal to 2 tick binary 1 1, which is connected y equal to inp of 3, like this. Okay, and here by using if case statement, how to write? So 4 cross 1 mux. If it is 4 cross 1 mux, case select. So here 2 tick binary 0 0. Okay, so y equal to what? Y equal to inp of 0. 2 tick binary 0 1, y equal to inp of 1. Okay, and 2 tick binary 1 0, y equal to inp of 2. 2 tick binary 1 1, y equal to what? inp of 3. Like this you will get the. So you need to write this. Okay, did you understood how to write? Can you write this? First declaration is there. First what you need to declare? So module. Okay, this is underscore 4 cross 1 mux. Okay, and you need to declare the inputs and outputs. Input. So here how many inputs are there? Input selection. How many selection lines? 2 selection lines. No, 1 down to 0. Yes. Input and how many inputs are there? 4 inputs. I am using a vector concept. 3 down to 0 inp. Okay, and output reg and y. Output reg y. Okay, and here in this always at the rate I am giving star. Okay, and begin. Okay, if it is case statement, you need to write this one. If it is if else statement, you need to write this one. That's it. End module. Did you understood how I am writing?
Sir, case study की default value.
What? Yeah, default. Yeah,
Case
default will
study की default value.
Yeah,
और
default. That is default y equal to 1 tick binary x. Okay, x will be there. Tick binary x. Is it fine? Will you try?
Okay, sir.
Okay. Testbench means testbench for 4 cross 1 mux. How to write? So same thing, same process. Okay. Testbench for 4 cross 1 mux. First, you need to initialize the testbench module. So what is my module? Module underscore 4 cross 1 mux underscore tb. Okay, tb. So you are not giving any inputs and output. That's why that is in bracket is empty. Step 1. What is step 1? You need to declare the internal variables. Same process. Declare the internal variables. Okay. So what are the internal variables? So
Input
for the
reg.
testbench, input initialize with reg data type. Reg 3 down to 0 inp, and next reg 1 down to 0.
Wire.
Yes. Okay, and wire why here you can give like in order to differentiate the test bench in inp underscore tb you can give, okay, s underscore tb you can give tb test bench, okay, and here also y underscore tb you can give, okay. Next you need to instantiate. Step 2 is nothing but you need to instantiate the design, okay, instantiate the design connection by position, okay. So how to instantiate underscore 4 cross 1 mux your design inputs, design dut, design under test, this is instance dut, okay, and here so connection by position means what, s underscore tb of so how you are declaring 1 comma s underscore tb 0 comma inp. Similarly inp of what, inp of so how you are declaring 3 down to 0, no, so inp of 3, inp of 2, and inp of 1, and inp of 0 comma y underscore tb, okay, imp underscore tb also there, this is imp underscore tb, okay, imp underscore tb, and drive the inputs. You can use for loop or you can drive some constant values, drive the inputs, okay. So here first this is step 3, this is drive the inputs is step 4. Step 2 is you need to initialize the internal variables, no. Step 2 initialize the internal variables, okay. So internal variables, that is so that is inp of inp underscore tb of 0 comma inp underscore tb underscore 1, inp underscore tb underscore 2 comma inp underscore tb underscore 3, and s underscore tb that is equal to what, using concatenation operator I am initializing to 0, okay. So like this you need to drive the test cases, okay. So what are the test cases you need to give? So 4 cross 1 mux you can give the test cases, means for loop also you can give, or by using normally you can give, okay. Yeah, can you try this this one 2 cross 1 mux, 4 cross 1 mux, same thing, 4 cross 1 mux you need to write with the case statement, okay. This is the program by using case statement, okay. So 3 down to 0, 1 down to 0, and reg y, okay. So this is always at the rate star, and so 0 0 means d0, you can use this one also, d0 d1 d2, and default statement is 1 tick binary x, okay. Why that default I will tell you in the next class. This is what this is by using assign statement, okay, continuous assignment statement. Assign y equal to what, select that is equal to 2 tick binary 0 0 d0, or select 2 tick binary 0 1 d1, or select 2 tick binary 1 0 d2, or select 2 tick binary 1 1 d3, or 1 tick binary x, okay. This is by using data flow modeling by using continuous assignment statement, okay, by using continuous assignment statement. So when you are using data flow modeling, all the inputs and outputs should be wire data type, okay, and this is by using if else statement, behavioral modeling. So module so input wire in output reg y, always at the rate star begin, if select equal to 2 tick binary 0 0 y equal to d of 0, else if select equal to 2 tick binary 0 1 y equal to d1, else if select equal to 2 tick binary 1 0 y equal to d2, else if y equal to d3, okay. And you write the code parallelly, you write the code and you elaborate by using if else statement and case statement. What is the difference, just you observe and tell me on Monday, you tell me, okay. And parallelly this is test bench also I wrote, okay. Test bench 4 cross 1 mux, test bench is same only, okay. So reg variables I need to initialize with d, and inputs I need to initialize with reg, outputs I need to initialize with wire. So here I am instantiating connection by name, So whatever the design inputs are there, those outside the bracket, and test bench inputs are there inside the bracket. Int I, initial begin, and dollar display these values. I am using how many inputs and outputs are there? 4 inputs and 2 selection lines, 2 power 6, 64 combinations I need to check by using for loop also. These are the test cases I am using. Okay, better to use for loop and see the all the cases. Okay, so test bench is common for both if else data flow and case statement. So just so here suppose if it is a case statement, set as stop, run the simulation, run behavioral simulation. Here you see, so fit to page. Here also you will get in the display statement also you will get, see here 64 combinations you will get. Okay, when selection equal to 0 0, okay, see here when selection equal to 0 0, which is connected, so this d0 is connected, whatever the value of d0 is there, so this is d0, whatever the value of d0 is there, that you will get the output. Okay, and when selection equal to 0 1, d1 is connected, d1, this second bit, this is connected to the output. And when it is 1 0, d2 is connected, d2, this d2 is connected. 1 1 means d3 is connected. Like this, you can see the output in TCL console, or you can see the output in the simulation window. Okay, so simulation window, just fit to page. So depends on this, you will get the simulation. That means this is the simulation output depending on the d value. Okay, depending on the selection line. First selection line is 0 0 means this d0 is connected to the output. Okay, what is d0? Here you see d0 means till here you will get d0. Okay, and whatever the d0 is there you are getting. Okay, and when selection line equal to 1, which is connected, d1 is connected. Okay, d1 is connected, and next selection line equal to 1 0, so this is 0 1 0 1, from here to here whatever the d1 is there, that is connected. Till here d0 is connected, and till here, see here, so when selection line is 1 0 1 0, from here to here, which is connected to the output, this one is connected to the output, that is d2 is connected to the output. Whatever the d2 waveform is there, that you are getting at the same thing. And when selection line is this 1 1, and d3 you are getting, so d3 also you are getting, so whatever the d3 you are getting. Okay, so like this you can see the waveform. Okay.